on. So let us now define what is called a general Lebesgue integral. So for that, first we'll define what do we mean by the positive part and negative part of a function f. So let us consider a measurable function f. The function has a positive part and negative part, and the positive part is denoted by f plus വെച്ചായിരിക്കും positive part denote ചെയ്യുന്നത്, and the negative part is denoted as f minus. And f plus is defined as maximum of fx and 0, and f minus is defined as the maximum of minus f 0. So which is same as minus minimum of f0. ഇനി f നമുക്കറിയാം f measurable ആണ്. So f measurable ആണെങ്കിൽ automatically minus f is also measurable. That's a constant multiple of f. And also we know that maximum of functions, maximum of measurable functions, that is again measurable, and minimum of measurable functions is also measurable. So f plus എന്ന് പറയുന്ന maximum ആണ്, f minus അതെ അല്ലെങ്കിൽ minimum. So you have either the maximum or minimum when you take f plus and f minus. So both f plus and f minus, they are going to be measurable functions. So let us look at how to express a function using the positive part and negative part. So the function can be expressed as a combination of positive and negative part. So let us see how that can be done. So consider the measurable function f. So if f is greater than or equal to 0, f plus എന്ന് പറഞ്ഞ f plus is maximum of f0. Now if f is greater than or equal to 0, in that case the maximum will be equal to f. So if f is greater than or equal to 0, f plus in the value f തന്നെ ആയിരിക്കും. And if f is less than 0, f in the value less than 0 ആണെങ്കിൽ, so the maximum is going to be 0. So f plus will be equal to 0. So in either case you can see that f plus is always greater than or equal to 0. So by the definition of f plus, the maximum is either 0 or f. So it will be always greater than or equal to 0. So similarly, when you take f minus എന്ന് പറയുന്ന maximum of minus f 0 ആയിരിക്കും. So when f is greater than 0, minus f negative ആയിരിക്കും. So maximum is going to be 0. And when f is less than 0, f less than 0 ആകുമ്പോൾ minus f positive ആകും, strictly greater than 0 ആയിരിക്കും. So therefore maximum will be equal to minus f. So both cases you can see that again f will be greater than or equal to 0. So sorry, f minus will be greater than or equal to 0. So f minus f greater than 0 ആണെങ്കിൽ f minus ന്റെ value 0 ആയിരിക്കും. f less than 0 ആണെങ്കിൽ f minus ന്റെ value minus f ആയിരിക്കും, which is greater than 0. So f minus will be also greater than or equal to 0 for all x. So therefore f plus and f minus actually non-negative measurable functions ആണ്. അപ്പോൾ നമ്മൾ non-negative measurable functions ന്റെ properties കണ്ടിട്ടുണ്ട്. So here f plus and f minus are non-negative measurable functions. And again, if f is greater than or equal to 0, so we have seen f plus is equal to f and f minus will be 0. So if f is a non-negative measurable function, അങ്ങനെയാണെങ്കിൽ f plus equal to f ആയിരിക്കും, f minus equal to 0 ആയിരിക്കും. അതുപോലെ if f is a non-positive function, so if f is less than or equal to 0, in that case f plus will be 0 and f minus will be minus f. So we can write f as f plus minus f minus. Okay, അപ്പം first case നമ്മൾ f plus minus f minus എടുക്കുമ്പോൾ f greater than 0 ആവുന്ന greater than or equal to 0 ആവുന്ന കേസിൽ so f greater than or equal to 0 ആവുമ്പോൾ f plus f ആയിരിക്കും f minus 0 ആയിരിക്കും f less than or equal to 0 ആവുന്ന കേസിൽ f നോൺ പോസിറ്റീവ് ആയിട്ടുള്ള കേസിൽ f ന്റെ വാല്യൂ again f plus minus f minus എന്ന് എഴുതി കഴിഞ്ഞാൽ നമുക്ക് കിട്ടാൻ പോകുന്ന f plus ന്റെ വാല്യൂ 0 ആയിരിക്കും f minus ന്റെ വാല്യൂ minus f. അപ്പോൾ minus of minus f വരും. So which is again equal to f. So in both the cases where f is non-negative measurable function and f is a non-positive measurable function, f can be expressed as f plus minus f minus. So f greater than or equal to 0 ആവുന്ന കേസിൽ f നെ നമുക്ക് ഇങ്ങനെ represent ചെയ്യാം. അതുപോലെ f less than 0 ആവുന്ന കേസിലും നമുക്ക് f plus minus f minus എന്ന് തന്നെ represent ചെയ്യാൻ പറ്റും. So given any measurable function f, it can be expressed in terms of the positive part and the negative part. So f will be f plus minus f minus. ഇനി ഇത് നമ്മൾ f നെ ആണ് represent ചെയ്തത്. അതുപോലെ നമുക്ക് mod f നെയും പോസിറ്റീവ് പാർട്ടും നെഗറ്റീവ് പാർട്ടും ആയിട്ട് represent ചെയ്യാം. So mod f will be equal to f when f is greater than or equal to 0 and it will be minus f when f is less than 0. So that is the definition of mod f. So when f is greater than or equal to 0, mod f is equal to f. Now f greater than or equal to 0 ആകുമ്പോൾ f plus ന്റെ value f ആയിരിക്കും, f minus 0 ആയിരിക്കും. So we can see that mod f will be equal to f plus f minus. Okay, f plus ന്റെ value f വരും, f minus ന്റെ value 0. So when f is greater than or equal to 0, mod f will be, this is equal to f. So we will get in the form mod f equal to f. ഇനി അതുപോലെ f less than or equal to 0 ആവുന്ന കേസിൽ നമുക്ക് mod f നെ f plus f minus എന്ന് എഴുതാൻ പറ്റും. അപ്പോൾ നമുക്ക് f less than 0 ആവുമ്പോൾ mod f ന്റെ വാല്യൂ minus f ആണ് കിട്ടേണ്ടത്. അപ്പോൾ f less than 0 ആവുമ്പോൾ f plus ന്റെ വാല്യൂ എന്താവും, 0 വരും, plus f minus ന്റെ വാല്യൂ minus f ആയിരിക്കും വരുന്നത്. So that will be 0 minus f which is equal to minus f. So if you write mod f to be f plus f minus, that will give you mod f equal to f when f greater than or equal to 0 and minus f when f is less than 0. So mod f can be written as f plus f minus. And again നമ്മൾ കണ്ടു f plus ഉം f minus ഉം രണ്ടും measurable ആണ്. So again രണ്ടും measurable ആണ്, f plus ഉം f minus ഉം measurable ആണ്, and both are greater than or equal to 0. So again this will be a non-negative measurable function. So mod f is going to be a non-negative measurable function. And now let us define when do we say that a measurable function is integrable over a set E. അപ്പോൾ നമ്മൾ നേരത്തെ എടുത്തത് first നമ്മൾ bounded measurable function kandu, then non-negative measurable function. Now we are taking any measurable function f. So we'll define the integrability using f plus and f minus. So a measurable function f is said to be integrable over a set E. So if both f plus and f minus are integrable over E. So f plus f minus non-negative measurable functions are, so they will be integrable if these integrals are finite. So integral over E f plus must be finite and integral over E f minus must be finite. So that is a condition for a measurable function to be integrable. Okay, so that is how we define the general Lebesgue integral. And now if f is integrable over E, we have seen integral f plus finite ആയിരിക്കും, integral f minus finite ആയിരിക്കും. Now by the representation we have seen, mod f can be written as f plus f minus. So integral over E mod f. So mod f non-negative function ആണ്. So that's a non-negative measurable function. So that will be equal to integral f plus integral f minus f. So that is less than infinity. So if f is integrable, integral f plus f minus less than infinity ആയിരിക്കും. So integral over E mod f also will be less than infinity. So mod f will be integrable over E. Conversely, mod f integrable ആണെങ്കിൽ integral mod f less than infinity ആയിരിക്കും. So integral f plus f minus is less than infinity. അപ്പോൾ രണ്ടിന്റെയും sum ആണ് ഇവിടെ വരുന്നത്. So if the sum is less than infinity, each integral must be finite. So if each integral is finite, then we can conclude that f is integrable over E. So that is an if and only if statement. So f is integrable over E if and only if mod f is integrable over E. So f integrable ആണെങ്കിൽ mod f integrable ആയിരിക്കും, നേരെ തിരിച്ചും. Now let us look at a proposition. So these are few results on integrability. So let f and g be integrable over the set E. Then the result states that the function cf is integrable over E. So f integrable ആണെങ്കിൽ, so if you take a constant multiple of f, that will be integrable, and integral over E cf will be integral c times f. അതുപോലെ f ഉം g ഉം integrable ആണെങ്കിൽ f plus g integrable ആയിരിക്കും. So integral f plus g will be integral f plus integral g. And again, if f is less than or equal to g almost everywhere, then integral over E f is less than or equal to integral over E g. ഇനി അതുപോലെ a യും b യും disjoint measurable sets ആണെങ്കിൽ, so integral over a union b f will be integral over a f plus integral over b f. So let us prove the first result. So we need to show that for any real number c, c is an arbitrary constant. C യുടെ value positive ആവാം, negative ആവാം, 0 ആവാം. So in all the cases we will show that integral cf is equal to c times integral f. So we will show that cf is integrable. So cf integrable ആണെങ്കിൽ we need to show that integral cf plus less than infinity and cf minus is less than infinity. So this is what we are going to show for different possible values of c. So first we will consider the case where c is greater than 0. So c greater than 0 ആകുമ്പോൾ cf plus will be maximum of cf0. So that is c times maximum of f0. So maximum of f0 എന്ന് പറയുന്നത് that will be f plus. So c into f plus കിട്ടും. അതുപോലെ c f minus എന്ന് പറയുന്നത് it will be c into f minus. Now since f is integrable, integral f plus less than infinity ആയിരിക്കും, integral f minus less than infinity ആയിരിക്കും. So when you take integral over E, cf plus that can be written as c times f plus. Ni the non-negative function ആണ്. So these are non-negative measurable functions. So you can take c outside. We have seen the results for non-negative measurable function. So c into integral over E f plus വരും. So that is less than infinity since this integral is finite. അതുപോലെ c f minus എടുക്കുമ്പോൾ again you will get c times f minus. So that will be c into integral f minus. So again the integral value is finite. So both the values are finite. Integral cf plus cf minus finite ആണ്. So we can conclude that cf is integrable. So this is the case when c is greater than 0.